Had to start the recorder there. Good morning, happy Thursday. A couple things. First of all, I hope you had a good day yesterday. And we actually started a new lesson in 2.1. I see that I'm hoping you all found Google Classroom, and I just sent a remind message about the code. But if you're here, you probably joined the link from Google Classroom. And we're on that special schedule this week with Monday holidays. So this week I met with you on Tuesday and I'm meeting with you on Thursday. Couple things, make sure if you don't have a calculator, make sure you get one. You can pick one up at the Rancho parking lot, Monday, Wednesday, Friday from 8 to 11. So this class requires a calculator. You have to have the calculator. Also, you need to have an online account, which I know if you had me, you should have your online account. It is important because to practice for exams and to do the globe problems for exams and the final, to take the final, you have to have an online account, which I think you do. And if you notice, the assignment that I'm going to finish today is due on Friday night. So you should have been able to get started on it. You should have been working on it. And I'm going to finish it up today, and it will be due on Friday night at 11:59. You are not to wait till the last minute to do it. Remember, I'm not taking any late assignments. So today what we're going to do, I'm going to finish the lesson, and then you're going to work in your Math Wizard teams on the even problems. Now, some of the groups were asking me, well, why are you making us do the evens when we have to do the odds? And here's the answer. If you would prefer me to assign 1 through 50, I can assign 1 through 50. So that way you would get the practice you need. But I decided to assign the odds and give you could pick the evens of your choice in the wizard teams. So so that's the deal. You either get all 50 problems or you work the evens in the Math Wizard teams today. All right, so that's why I didn't assign 1 through 50. Okay. So yesterday we looked at lesson 2.1, and I only went through 2 objectives. I went through adding and subtracting and multiplying complex numbers. So today I'm going to do 3 objectives, and we're going to work in the Math Wizard teams. All right. Anybody have any questions about what I did yesterday? All right. Well, let me finish the lesson then. So we're going to talk, the 3rd objective is dividing complex numbers. Complex numbers, by the way, are imaginary numbers. Just a reminder too, that you committed to showing your face, and you don't have to do that now, even though you're supposed to. But in the Math Wizard teams, you committed to showing your face, and I don't want to have to every day say, show your face, show your face, show your face. It's your fault if you didn't get up and get ready. It's your fault if your hair's messed up. It's your fault. So you committed to show your face. So that's what I expect you to keep your commitment, unless you're a liar, which I know you're not. So if you committed to showing your face, show your face. All right. So dividing. So that's a complex number divided by another complex number. Now here's the deal. In the directions, they will say to simplify and write in standard form. Now, standard form is A plus BI. So I'm going to write that up here. All your answers are to be written in standard form. We talked about this yesterday, A plus BI. Now, the reason why there's a problem here is because I is a radical. And remember, you cannot have a radical in the denominator of a fraction. So remember first semester, I went over the conditions for simplifying radicals, and I said, number one, you can't have any perfect squares in there. Number two, you can't have a fraction under a radical. And number three, you definitely can't have a radical in the denominator. So we have to get rid of that radical, which is I, in the denominator. And the way we're going to get rid of it is we're going to multiply by 1 in the form of the conjugate. So this is called the conjugate. It's actually called the complex conjugate. And what that's going to do, it's going to help us get rid of this I on the bottom. So let me show you what happens here. So on the bottom, we FOIL, right? And it just so happens that when you FOIL conjugates, you don't have to do the outer and the inner because they're always opposites and they cancel each other out. If you don't believe me, do the full FOIL. So on the bottom here, we're going to FOIL. But like I said, with complex conjugates, the outer and the inner will always cancel themselves out. So watch. We're going to multiply the first ones. 2 times 2 is 4. And then the last would be a negative times a positive is what? Negative 25i squared. Negative 25i squared. You guys okay or no? Let me pin myself because I can't really see the board the way you're seeing it. So let me just pin myself real quick. Okay, there, that's better. Okay, so on the bottom still, you have 4 minus 25. Remember yesterday we said I squared is -1, so you put in a -1. And you can skip this step if you want. So if you want to write 4 plus 25, fine, but I'm not going to. I'm going to skip it. 4 plus 25, right? Negative times a negative is a positive would be 29. So when you multiply by complex conjugates, you're always guaranteed a nice number in the denominator. So that's why we did it. And that's why whenever you have a complex number in the denominator, multiply by the complex conjugate. All right, so what happens in the numerator is you have to do a full FOIL. So first, outer, inner, last. So 7 times 2 is 14. This times this is a 35i. The inner would be 8i, you're multiplying. And then the last would be plus 20i squared. So you just simplify this. This would be 14. A positive and a positive would be what? 40? Is that 43i?
Yeah.
Thank you. And this would be plus 20 times the -1 because we have to take the I squared out. So now what you have is 14 plus 43i minus 20. So you combine these terms, a positive and negative would be a -6 plus 43i over 29. Now, yesterday, I said you cannot simplify an expression. I kind of lied a little bit. When you have a fraction that's an expression, if you can divide all 3 terms by the same number, you can simplify, as long as you do the top and the bottom. Now, since 29 is prime, you can't simplify this. This is simplified, but we do have to write it in standard form. So your final answer is going to be -6 over 29 plus 43 over 29i. And that is your final answer. Okay, now I only have one of these examples in my notes, but do you want me to work another example on this?
Yeah.
Okay. Okay, do y'all have this written down? Okay, I'm gonna erase it. So some students ask me, you know, it's like, should we be writing it down? Well, I'm not writing this down for me. I know this. You know, I've known this for like 40 years. So whenever I write something on the board, it's for you. It's not for me. I already know it. So you should always write things down that I write on the board, unless I specifically tell you not to. You should always write stuff down. Okay, I'm going to pick a problem out of your book, and I'll pick one of the odd ones. So I'll do number 25. So in lesson 2.1, I'm on page 314. So you should open up your books to page 314. I'm doing problem number 25, which is in your assignment. So we have 8i over 4 minus 3i. So we have a radical in the denominator. So I would put this in parentheses, and we're going to multiply by the conjugate. So the conjugate is 4 plus 3i. You just change the sign in the middle. 4 plus 3i. When you do that, you're going to get a nice number on the bottom. So watch. So remember what I said. When you're multiplying complex conjugates, the outer and the inner are going to always cancel out. If you don't believe me, just do the whole FOIL. Go ahead. I'm just trying to save you time. So 4 times 4 is 16. And this would be what? Negative what?
9i squared.
Yes, 9i squared. So you get 16 minus 9 times negative 1. And if you want to show 16 plus 9, fine, but I'm not going to. 16 plus 9 is 25, and I'm going to be done with it. If you want to show an extra step, go ahead. Now notice I didn't skip this step. I skipped the one that I can do in my head, 16 plus 9. So don't skip important steps. Okay, so in the top, we have to distribute by multiplying. So that would be 32i plus 24i squared. So now we take out the I squared and put negative 1. And we have to write this in standard form. So I'm going to put the negative 24 in front. In other words, I'm just going to switch them because I'm trying to write them in the form. Now, if these were all divisible by 2, divide. If these are all divisible by 5, fine. But they're not divisible by the same number. So you can't divide the 3 terms by the same number. So you're done. Just write it in standard form, which would be negative 24 25ths plus 32 over 25i. Okay, so that's how the division problems work. You're going to get rid of that I by multiplying by the conjugate. You're going to always, when you multiply by the conjugate, you're going to always get a nice number in the bottom. And in the numerator, you might have to distribute or FOIL. If it's a pure imaginary, you're going to distribute. If it's just a complex number, you're going to have to FOIL, like in the first problem I did. Okay, do you guys have any questions before I erase this? All right, we're on objective 4 then. And that's performing operations. With square roots. Of negative numbers. Before I start this, I want you to recall something. So recall when we had like square root of 2 times square root of 3. Remember the answer is just square root of 6. Yeah.
Yes.
Well, you can't do that with imaginaries. We use the product property. And the product property won't work for imaginaries. So watch. So this problem kind of looks like that one. And don't make a mistake. This looks like the square root of 100, which is 10, but the answer is not 10 because you cannot do what we did up here. So what you have to do with imaginaries is you have to pull the I out first. So you're going to pull out an I because there's a square root of negative 1, right? And now what you have is you have 5i times 2i, which would be 10i squared, which is 10 times negative 1, which is negative 10. So let me say this again. You have to pull the I out right away. So once you see the square root of negative 1, pull an I out. Square root of negative 1, pull an I out. Then you simplify the radical. 5 times 5, a 5 comes out. 2 times 2, a 2 comes out. Multiply 10i squared. Take out the I squared and put a negative 1, and the answer is negative 10. So the product property does not work for imaginaries. Okay, let's do a few more problems, okay? Okay, this is a subtraction problem. And remember before I said that you could add or subtract like radicals? Well, those aren't like radicals. So what I'm going to do is I'm going to simplify them and see what I get. So I'm going to do a prime factorization on 18 and pull out an I. And I'm going to do a prime factorization on 8 and pull out an I. So I'm just going to do this in my head. 2 times 9 is 18, right? 2 times 9. So wouldn't that be 2 times 3 times 3? And isn't 8 2 times 4, which would be 2 times 2 times 2? So if you have to do the prime factorization off to the side, that's fine. Go ahead. Depends who you are and where you're at. Okay, what comes out of the first radical?
3.
What? 3? Who gets stuck?
2.
Who comes out of the second radical?
2.
Who gets stuck?
2.
Now look at that. Aren't those like radicals? Isn't square root of 2i and square root of 2i? Aren't those like radicals? So don't we just say 3 minus 2 is 1 and keep the radical the same? Remember we had like 2xy plus 3xy is 5xy, right? Don't change the variables, remember? Well, isn't 3, these are like radicals, isn't this just 3 minus 2 is 1 radical 2i? Can you guys see it or no?
Yeah.
Can the rest of you respond, please? Do you get it or not? Because if you don't get it, let me know.
Yeah, I got it.
Okay. So only 2 people get it?
Got it.
I got it.
Okay. Okay, let's do another problem then. Okay, you cannot deliver the power across a sum, right? So when you have a product, you have to deliver the power, 4x squared, y squared. But when you have a sum, you do not deliver the power. So what does this mean? This means FOIL. It means -1 plus square root of -5 times -1 plus square root of -5. And like I advised you at the beginning, take out the I first. So when you see a square root of a negative, that's square root of -1, so take it out. Square root of a negative means take out an I. Now FOIL. So now FOIL. So a negative times a negative is a +1. The outer would be a -1 radical 5i. The inner would be a -1 radical 5i. These are not conjugates, by the way. And so what's a radical 5 times a radical 5? What's a radical 5 times a radical 5? Isn't that radical 5 times 5, which is what?
Radical 25.
Well, if you have a radical 5 times 5, doesn't a 5 come out? Why would you multiply it out? 5 comes out, right?
Oh yeah, sorry. Yeah. I see it now.
I know you do, Mark, but what about everybody else? Radical 5 times radical 5 is radical 5 times 5, a 5 comes out. So a 5 comes out, and then when you get I squared, right? FOIL, first, outer, inner, last. So now when you combine the terms, this would be 1, a -1 and a -1 is a -2 radical 5i. Don't change the radicals. And this would be +5 times -1 when you take out the I squared, right? Yes.
Yes.
So I'm going to skip this step. This is -5 plus 1 would be a -4, isn't it? Isn't a -5 plus 1 -4?
Yep.
Yeah.
Mine is 2 radical 5i, and isn't that written in standard form? And notice I can't divide by 2 because this isn't a fraction. This is an expression. So if it was a fraction, we could divide everything by 2, but this isn't a fraction. So you're going to mess up the problem. Leave it alone. Okay, go ahead. I'm taking questions if you have any. So a lot of you are not saying anything, which concerns me. So if you have a question, make sure you ask me. Okay, can't cancel parts of a sum or difference. So get the I out of there first. So this would be -25 plus radical something I. You're going to do a prime factorization on 50. So if you take out a prime, Yeah, 5 times 10, take out a prime is 2 times 5. So this is going to be 2 times 5 times 5. So who gets to come out?
Five.
Who gets stuck?
2.
Okay, now look at this. Don't you have a fraction? And don't you have 3 terms that you can cancel a 5? So don't you have to cancel a 5 in all 3 terms? This is one term because it's all a product, right? So can't you divide everything by 5?
Yeah.
Okay. So divide by 5, divide by 5, divide by 5, and then write it in standard form. So this would be negative 5/3 plus radical 2 over 3i. Okay, anybody have any questions before I teach the last objective? Well, just a reminder, you're not going to see me. And the assignment's due on Friday night. So you got to stay on top of your questioning. If you have questions, make sure you ask me. Assignment's due on Friday night. This is Thursday morning. If you have any questions, make sure you ask me. All right, here's the 5th objective. We're going to solve quadratic equations. With complex imaginary solutions. Now, you know that normally when we solve, we can see where the graph is crossing the x-axis. That's what solving is. So when we find x's, that's where it's crossing the x-axis. But when you get imaginary solutions, the imaginary solutions, you will not see them in the Cartesian coordinate plane. So in other words, you might see the parabola looking like that. That's when it has imaginary solutions. So you're not going to see it crossing the x-axis. You're not going to see imaginary solutions in a real plane. All right, so let me say a couple things here. First of all, I want to remind you about the general form of a quadratic. It's ax squared plus bx plus c equals 0, where a cannot be 0, or you'd have a linear. You have to write the quadratics in this form to get a, b, and c for the quadratic formula. What is the quadratic formula? The quadratic formula is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And then one more thing, the discriminant is what's under the radical, b squared minus 4ac. And I'm just telling you that if the discriminant is negative, you're always going to get 2 imaginaries. And the imaginaries come in pairs. So if the discriminant is negative, you get two imaginary solutions. So let me show you what I mean when I do the problem. All right, so check this out. Okay, now, in order to get A, B, and C for the quadratic formula, it must be in this form. If it's not in this form, you have to put it in the form. That means you might have to subtract 4 from both sides. You might have to add 2 to both sides, but you have to put it in the form to get A, B, C. So this is already in the form. So our A is 3, our B is -2, and our C is 4. So here we go. X is equal to -b, negative of a negative. X is equal to -b plus or minus square root b squared in parentheses, or you'll get it wrong. B squared minus 4ac all over 2 times 3. So x is equal to a +2 plus or minus the square root of a negative. Squared is +4. And that would be a negative times a positive is a negative. 12 times 4 is 48, right? All over 6. So this is going to be 2 plus or minus the square root of -44 all over 6. Now, remember over here, I told you if the discriminant, which is under the radical, if it's negative, you have 2 imaginaries. It's negative, so you're going to have 2 imaginaries. So real radicals always come in pairs, and imaginaries always come in pairs, in 2. So here we go. X is equal to 2 plus or minus the square root of something I divided by 6. And the prime factorization of 44 is 2 times 22, 2 times 11, which would be 2 times 2 times 11. So x is equal to 2 plus or minus, who gets to come out? A 2? Square root of 11i over 6. And now that we have a fraction, and we can simplify in all 3 terms, right? 1, 2, 3. Can't we divide everything by 2? Shouldn't we divide everything by 2?
Yes.
So divide by 2. Divide by 2 is an invisible one. Divide by 2, and now we have to write it in standard form. So that would be 1/3 plus or minus square root 11 over 3i. Now in algebra 2, I make them write the answers in a solution set. So in algebra 2, I make them do this. 1/3 minus radical 11 over 3i. And the second solution is 1/3 plus radical 11 over 3i. I'm not having you do that, but I'm just letting you know that you did find 2 solutions. And these solutions, by the way, are complex conjugates. always look like something minus something, something plus something. All right, well, guess what? I finally finished the lesson. Thank goodness, right? So I finished the lesson. So here's what you're gonna do. You have new Math Wizard teams. So you're gonna go into your Math Wizard teams, you're gonna introduce yourself and say who your hero is and why. So it could be anyone. Who's your hero? So I'm gonna listen to me because I want you to do this. I'm gonna get upset if you don't do it. You're gonna introduce yourself, right? You're gonna show your face, you're gonna introduce yourself, and you're gonna say who your hero is and why. Then what you're gonna do is on page 314, Mark's gonna pick a problem. So Mark's gonna say, oh, well, I would like to do problem number 22. Now you can only work the evens, you're not working the odds. And then after you work 22 together, you know, Jaden might say, well, I want to work problem number 12. So you're all going to work problem number 12. So just a reminder, you're not working individually. You're talking out loud. You're talking through the steps and you're working the problem together. Okay, make sure you write the original problem. Make sure you write vertically and make sure you circle your answer. And hopefully, after you pick out these problems in the different sections, you will be able to do the odds on your own. All right? Okay, we will not be checking back. Class is over at 12:10. You have a lot of time to work together and get some problems resolved. So make sure, I'll say it one more time. You're going to introduce yourself, go to the Math Wizard teams, introduce yourself, say who your hero is and why. And then you're going to take turns picking different evens on page 314 to clear up any problems you're having with certain sections of problems. All right, we are not going to report back, but I will be taking attendance in the Math Wizard teams. All right, so I'll see you in your teams.